In the preceding lecture, we discussed about the bricks in detail. Now let's take the other part, the timber. Timber is considered as the oldest material of construction right from the prehistoric times till date. Timber has been used in building constructions, bridge construction, and other engineering constructions. Even in the railway constructions, we use the timber. Timber has been used excessively due to the like properties like color and order, specific gravity, moisture content, shrinkage and swelling, and strength. Timber is basically a naturally occurring material and is also renewable and is quite satisfactory engineering material. This is attributed to its engineering properties like lightweight, better strength, and it's easily workable as well as durable. If we talk about the property of color and order, we may have a variety of colors present depending upon the source from which wood is obtained. For example, walnut wood is typically dark brown in color. Likewise, soft woods like deodar or pine are light white in color. Few woods are immediately identified from characteristics of smell, like teak wood, which has an aromatic color. Now, the specific gravity. Wood is a light material with specific gravity being less than 1, is that it has the specific gravity less than that of water. This is why wood floats over water. Then we have the moisture content. Woods being porous in structure or hygroscopic is that they gain moisture from the atmosphere. If we talk about the property of shrinkage and swelling, a newly cut wood loses moisture when subjected to drying and undergoes shrinkage. When subjected to drying, it undergoes shrinkage. Similarly, on getting soaked with water, wood may undergo considerable swelling. Then we talk about the strength property. The most important factor about strength of wood is that it is anisotropic. Anisotropic means it has different properties in different directions. Is that the properties are not same in all directions, and hence the strength of wood is determined with respect to its direction. If we talk about the compressive strength of the wood, the compressive strength should be around 500 to 700 kilogram per centimeter square. Timber is very strong under compressive loads. However, it should be noted that the compressive strength parallel to the grain is always less than that determined at right angles to the grain. Grain means the direction in which we talk about the strength. Then we have the tensile strength. Woods are very strong to tensile forces along parallel direction and very weak along perpendicular direction. The value of tensile strength is from 500 to 2000 kilogram per centimeter square along parallel direction and only 10 to 100 kilogram per centimeter square along perpendicular direction. The most important use of timber as a beam is based on the fact that it has very high bending strength, is that 300 to 900 kilogram per centimeter square. Now if we talk about the defects in the wood, a defect in timber is defined as any undesirable character, natural or artificial, that lowers down its strength, durability and quality. The defects may be natural or artificial. If we talk about the natural defects, they are shakes, knots and cross grain. If we talk about natural defects in general, the defects are developed during the growth of wood or the growth of the tree, and their development cannot be controlled. Most common defects are shakes, knots and cross grain. If we talk about shakes, shakes are basically cracks or fissures in general, and they are very common defects. They are most serious defects and they are very common. They are basically cracks or fissures which may result from aging of the tree or due to the winds. They may be heart shakes, the star shakes, ring shakes, depending upon the position at which they get developed. Heart and star shakes get developed as it can be seen from the figure. Heart and star shakes get developed as we see from the figure B here, they can get developed in the hardwood. They can get developed along the periphery as well. Ring shakes. If we talk about the ring shakes develop parallel to the annular rings, whereas the heart shakes are developed towards the inner region. Is that the heartwood? Star shakes are also called as radial shakes. They generally develop in the sapwood and extend inwards. As it's obvious from the figure, you can see the heart shakes. You can see, first of all, you can see the annular rings. Then determine the age of the wood. Then you can see the heart shakes. Then you can see heart and star shakes. And finally, you can see knots as well. If we determine the knots, what are knots? Knots are basically, a knot is a mark of the position of growth of branch on a tree, and on cut boards it is mostly seen. You can see from the figure the knots have been shown here. Then if we talk about the cross grain, fibers in the wood in a normal tree are usually parallel to the axis of the length of the timber. This structure is called straight grained. In some cases, however, these fibers are not straight and they make angle or slope with the axis of the tree. They are called as cross grains. They are quite defective as compared as compressive and tensile strength of wood is quite related to the direction of fibers. The slope should exist within specified limits. If we talk about the artificial defects, these include such defects that get developed in timber after its felling and conversion into different sizes. They are the most important artificial defects include the checks and warps. Checks are most common. They are cracks or defects that get developed longitudinally in the logs after their felling. When a log of wood remains exposed to atmosphere only on one side, the upper side loses more moisture than the lower side. This will result in the shrinkage in the exposed region to such an extent that tensile forces sufficient to cause a crack in the wood would be easily developed. If we talk about the warps, warping is deformation in the original plane surface of the board cut from the timber. This is attributed to unequal shrinkage. The warping may be a bow, a cuping, a twist, as shown in the figure. You can see, first of all, the figure A shows a normal wood. It has the dimensions of A and B in the both respective directions. Then the figure B shows bowing, the figure C shows cuping, and figure D shows twist. These defects are with respect to the change in the dimensions. Okay, then we have another topic, that is the seasoning of the timber. Seasoning means to lower down the moisture content of the wood to acceptable proportions before being used or before any use, as we have seen that the defects get developed as a result of moisture content present in the wood. Seasoning is a process of removing excess content of moisture from the wood to acceptable proportions. There are the objectives of seasoning, that I mean, why is seasoning required? Seasoning is required because it results in the following advantages. First of all, it is a reduction in the weight. Before the timber logs are transported, they are put to seasoning in order to expel the moisture content present and to decrease down the weight due to the presence of weight content in green wood. Then we have increase in strength. Moisture content in the cell walls and cell cavities decreases the strength of the timber. Higher the moisture content, lower will be the strength of timber. Then we have workability. Timber has to be cut into the shakes, into smaller boards and planks. Green timber would be more difficult to work with compared to the seasoned timber. And the durability. Moisture invites a number of microorganisms and insects to thrive on its sap, which may destroy the wood tissue, and hence moisture content should be expelled out.